And let's kick it to Tim Dwyer right now.
Well, welcome to who knows what day of lockdown, right? I don't. I've lost track. So let me share my screen here. Or not. It's interesting. So
I use this. Oh, go ahead.
Oh, I see what you're seeing already. Well, that looks like a mess. So we're going to go one to the right here. Okay.
There you go. Now we're seeing your screen.
Yeah. Well, and we're probably going to have to come back here for Kevin whenever we go to him. So I'm going to bump this up just a little bit here. Okay. A little latency, but not bad. Okay, again, welcome to Make a Lockdown. You guys have to be going somewhat stir crazy. Hopefully that some of the stuff that some of the resources that we brought to you have helped at least comfort you. If not, maybe you take them back and use in your classroom. And I say your classroom, your empty classroom or your virtual classroom. Hopefully some of your students are benefiting from this too. But what I want to do today is I want to go back to the engine bench that we used the other day, and we were going through and doing student-led type of activities where the student could walk up and actually put a fault into an engine bench and have to diagnose it. And then there was that corporate diagnosing campfire thing that I talked about where everybody got to kind of share ideas and walk the thought process through of how to diagnose an engine performance problem. On that engine bench, we have instructor-led lessons also. And so today I want to kind of go into that and show you some of the capabilities and features of doing that, okay? Because as an instructor, I mean, when I was teaching, I had a fleet of cars that half of them didn't run because of a fuel pump or a battery, but the ones that did were very hard to put accurate bugs into them or replicate part failures that you're going to see in the real world. And that's where I think that, our engineering team has done a really good job with putting what we're going to call case studies into, the computer of a Hyundai engine bench. And so wouldn't it be cool as an instructor to be able to put in repeatable, dependable, consistently, and realistic faults that actually cause the engine to perform the way it's supposed to, or it would in a type of a mode. So, like I said, we're going to look at an instructor-led version or lesson on map sensors. We're going back to the REM 140, which is our part number for a 2014 Hyundai Accent G4FD, which is a GDI 4-cylinder engine, and it's got a manual transmission. Probably want to start off talking about what a map sensor is, and this is why I'm saying it's instructor-led. We're going to be having the students around the bench and perhaps virtually. Hopefully soon we'll all be back where we can have some hands-on. But in the meantime, we would talk about manifold absolute pressure sensor, and I'm kind of a firm believer that most of our training stuff is you can learn a lot on it, but some parts like the engine benches, I think you need to walk up with some pre-knowledge. So this would have been a lesson perhaps you'd gone over in class. They'd done some research. However you got them ready to actually go out and manipulate the data on a map sensor to watch what it does to an engine performance. So, you would probably talk about a map sensor being like a fuel and timing type adjustment sensor that inputs to the computer. You might have gotten into the construction, of a map sensor. What does it do? It has a 5-volt reference, and it kind of like manipulates that 5 volts, and it does it through the old, semiconductors, like a silicone piezoelectric type of a sensor that is sensitive to pressure, and it varies electrical resistance depending on pressure. So we know in an intake manifold that there's, with the engine running, that there's vacuum suction, so to speak, on one side of the throttle plate, and then close to atmospheric pressure on the other side. that little crystal is sensitive to that pressure change, and it varies the resistance of that 5-volt circuit, and the computer is basically catching that signal and interpreting it into the load on the engine. Full throttle, cruising, idle, etc., or engine totally off kind of a thing. So lot to be discussed here. This could be almost a half of a day or a day's discussion, just getting to the point where you go and actually try and find it on an engine and mess with it. It's probably good to review what the voltage, the expected voltage values are, especially since, we have a breakout box on our engine bench. If you're brave enough to let your students back probe the computer, this would be some of the voltages that they'd be looking for, or, scan tool data. So, normal is, say, a volt to 4.5 volts. At idle, it's going to be pulled down to around a volt and a half. And then if a wide open throttle, it's going to be about 4.5 volts, something like that. So I think before any kind of fault scenario is ever, I guess before you expose your students to any kind of a fault, they should probably know what known good looks and sounds like. So what I want to do is a couple things. I want to back up to our lesson last week, and I want to be repetitive. I want to say that before any student does an electrical, an electronic, or a no-code drivability problem, or even a code drivability diagnosis, they need to make sure that the battery is good. And open circuit voltage should be tested before you proceed on. These are snapshots from a couple weeks ago when we did it. I'm not going to have Kevin do it again today, but generally it was at 12.4. We decided on a state of charge chart that's around 70% state of charge. I think by the textbook, you would probably want to charge the battery up to 12.6 before you went on, but we proceeded on, and then I had them check charging system voltage, which would be starting the engine up and testing it. And I think I always use the rule of thumb of it's got to be, or should be around 2 volts higher than open circuit voltage. So we have here the engine was running actually, even though we had a fault in it that prevented the tach from running. This engine was running and it was charging to 14.2, something like that. Okay, what I want to do now is go to a scan tool, and I want to pull up some live data so that we can start a known good engine and start looking at that data and familiarizing ourselves with it. So this is where it's going to get really kind of fun. Autel scan tools have an app or a feature in it, and when I taught team-based learning, which I was real big on teamwork in a classroom. We're meeting right now in Teams, an app on for Microsoft where we can all cooperate and actually share information. This particular app that the Autel has is called TeamViewer, and I'm going to say the team that's been watching our webinars contributed to me being able to do this, and I thank Dan Beeson for bringing up this feature. I'm not out in the field every day. I'm not teaching every day. I don't use an Autel as much as some people do. And Dan said, well, you can go and it has a TeamViewer app on it, and you can control the scan tool from where you're at. So just for fun, I'm in Oklahoma. The engine bench and the scan tool are in Quebec City, Canada, and I'm going to connect to it from here. Hang on. Okay. So I'm going to diagnostics. I'm going to connect on Hyundai, or Hyundai as people pronounce it. I'm going to let it do an automatic selection. I'm going to let it read the VIN number because I always joke and say our engine benches died, and that VIN number died and donated its organs to our engine benches. So this particular one, there's the ID for that car. I will say okay. It's retrieving, obviously, the VIN information, decoding it. USA version kind of confirm that information is correct. It's a 2014 1.6, and that's the VIN number. Say yep. Now it's doing just what it says. I'm going to go into diagnosis. I'm going to do an auto scan. This is a little little bit of a time bandit, but it goes through and scans all the component of the computers basically on the car. And if you'll notice that I intentionally left a fault in the engine, and it read that there is a pending or a code in a DTC that's pending in there right now. I don't know how many of you all use Autel. Been pretty impressed with just what I can do with it, even remote, and the times that I have been to Quebec City or we have had it at a show or whatever. Seems very versatile. I'll show you some other features over here too. I'm not an Autel sales guy. I just think it's kind of cool. So it's going through and checking everything, body control modules and immobilizer. Came back everything except for fault code in the engine, and I'm going to say okay and go on. So let's go real quick while we're here and just read the code. And since we've been dealing with map sensors, the code that's in there is one that Kevin and I put in about an hour or so ago when we were playing around with this. So it's a map sensor, circuit input low. Let me just go ahead and back out of there, and let's just clear it. And I'm going to ask Kevin, engine on. I'm sure it is. I mean, the engine's off and keys on, or I wouldn't be seeing this. So I'm going to say yes.
Yeah, we're good.
Okay, so it's cleared the codes. I'll go back. I've always got a real compulsive thing about me where I want to go back and read them again just to make sure that there isn't anything in there. So I'm going to back out. Now I'm going to say, let's go to live data, and let's take a look at a known good one here, but I want to kind of select what I want before we start observing. So it's pulling up all the PIDs right now that it can read, and circling of death there. What I found, and from a remote standpoint, if I start to try and scroll, I mean, it's real latent and it freaks out and it spins to the point where I can't even control it. So I spent a little time here in the past couple of days going through and getting, can you see my cursor? This little code right here. Oh, I'm actually moving it around. And long story short is it has a drop-down menu here that has a search function, and I've already pulled up the codes for that I want to pull into my own little file and monitor. I don't want to monitor all of these components. I'm just looking for the three that I'm going to pick. So they have codes on them, and one is 090, and it's a map sensor. Click on it. I can go back up and go 091. It's intake manifold pressure. I can click on it, go back over here and go 97, and I want intake air temperature sensor, and I'll show you why in a little bit. And then I can go down here to show, and it's just pulled those three out of that whole list, and now we're going to watch them. Okay, whoops, I'm going to hit that just show instead of show all. Now, they have another cool feature that we can look here and see the voltage reading right now, and you can see it moving. You can see that it's pretty close to barometric pressure right there. And then we have an intake air temperature of 91. We had the engine running a little bit earlier. So, but I want to do this too. I want to go ahead and drop this voltage menu down, and you have a choice of a gauge, just the text that you're seeing right now, a bar graph, or a graph. And I want to kind of I want to look at this. So right now with the engine off, you can see up here in the corner, it's 3.94, almost 4 volts. On that PowerPoint slide that I said, 4.5 is wide open throttle. Ask your students, why is it showing wide open throttle when the engine's off? And it has to do with the fact that, the pressure on both sides of the throttle plate are pretty much equal right now, correct? Get a good discussion going out of that. So let me try this. So Kevin, can you go and go ahead and start it up? And I'm going to go back to that data. Can you hear me, Kevin?
Yeah, I'm just unmuting myself so you guys can hear the engine.
Okay, starting and running. I'm going to go back to the data real quick. So you can see the voltage dropped down and it pulled it down to it's right now about 1.1, 1.2 volts, which is what I had said in that, obviously in that previous PowerPoint slide, that with it running at idle, it's going to be closer to 1 volt. With it off, it's going to be closer to 4.5 volts. So we spent some time here basically verifying what a known good engine looks and sounds like. Since we can kind of still hear Kevin, can you rev it up? Man, all that power. Should have got a Corvette in here or something. Okay, so you can see the graph moves in response to throttle position. You can see the pressure changes, and if you're watching the voltage up here, you can see the voltage changing. Again, learning moments for your students. Okay, so go ahead and Kevin, turn it off and turn the key back on. I'm going to go and say, now we have a customer complaint. So the students have seen the known good engine. I want to show them the customer complaint. Engine is hard to start and the check engine light is on. Now I'm going to walk you through this. The other day when we had this, we call it the HMI, but our interface to insert case studies into the engine bench, we were having a little bit of trouble with it timing out on us. We have since updated the software on it, and the time that Kevin and I have spent with it this week and late last week, it's pretty well cured. We haven't had any kind of issues like that at all. Because this is distance learning and we had a little bit of a problem last time, I made screenshots just to kind of get me where I'm going, but I'm gonna, I feel like there's still some there's a good point to being repetitive, and I'm going to show you on these slides, and then I'm going to transfer over to my tablet and show you what it looks like doing it live, and at the same time Kevin's going to actually be doing it on the engine bench. So the first thing we do is we actually dial in and remember I said the blue case, or anything in blue is student accessible, and we have actually gone up into, and I can't see it because I have a little deal blocking it, but I've unlocked the instructor portion, which has opened up these orange buttons down here. And we're going to go into the instructor case study and open it up. And then there's a menu over to the side, which is more enhanced than the student version, because we have more things that we can actually walk them through, like this lesson that we're getting ready to go through today. So I'm going to pick map sensor lesson, and I'm going to click on it, and I'm going to have Kevin actually do this at the same time. But he's selecting ICS, which is instructor case study, and it's number 11, and it's going to produce this P0107 code. And from an instructor point of view, you get this information. Now let me do this real quick. I'm going to go over to my version. I've got the same HMI tablet here. You're looking at what I'm doing to it. So I'm going to kind of do the exact same thing I just told you a minute ago. I'm going to do it live, and then Kevin's going to be doing it on the engine bench. So instructor mode, I'm going to put the pin in. It's going to highlight the orange keys. I'm going to scroll up. I'm going to select instructor case studies, and you can see all the ones that we're on the student deal are here too, but I'm going to go down into map sensor and select that. And then I'm going to select instructor case study number 11. I'm going to start with that one. What I like is that it basically up here, it tells you the case study. It's telling you what the code that you're going to expect. The scenario number, I'll show you that in just a minute. It's this is going to be the description, map sensor circuit low. Problem is, and again, we've written, this is an instructor-led lesson where you can demonstrate creating a map code. You should clear all codes before beginning the lesson. We did that. In this case study, the map sensor signal is interrupted, and we're going to put a big 0 in there instead of the 5 volt reference, or the 1 volt that it has at idle, or whatever. This will be a P107 code. Performance isn't affected a whole lot because the mass airflow input kind of compensates for it. So it's kind of like the car is healing itself to a degree, but it's going to set a code and turn a check engine light on, and hopefully bring the customer into the bay. We also make a note here that it's important to know that this fault doesn't change the sensor itself. I mentioned this last time. We're actually interrupting the signal between the sensor on the engine and the computer with our case study or our fault box. So if the student were to go out and measure anything at the sensor, they would get a good reading. The sensor actually is doing what it's supposed to be doing. We've kind of caught the signal on the way back to the computer. Okay, so, and from here you also have quick links to wiring diagrams in the breakout box. I'm going to show you something here real quick too. I go back to the student stuff. They have access to wiring diagrams, the factory wiring diagrams. And I showed you last time that you can pinch and zoom just like a regular, like we're all used to, so to speak. In the instructor mode, there's this wiring diagram with faults. And I'm not gonna click on it now because basically it shows where all the faults are wired into this system. And I don't necessarily want that on a YouTube video right now for your students to go be able to look at later and figure out what's going on. But I'm telling you that as an instructor to instructor, you're going to have resources here that are going to help you know where everything's at, what codes are going to be generated, what pin. I like it back up here too. I'll go back to that same one, map sensor 11. It's telling you, hang on a second here. I thought I told you what pin you were going to test it on. Anyway, so Kevin,
I'm good.
let me go back to you here if I can do this. Have you already inserted the fault?
Yeah, I'm good.
Okay, I'm going to slide over here real quick to the scan tool data because now it's still live. It's showing 0.04. Like I said, and this isn't any real secret. We're not having the students try and diagnose. We're telling them what we're doing. I'm showing them. I'm taking basically the 5-volt reference away, or I'm sending the signal, cutting the signal back to the computer down to almost 0. And so the scan tool reflects it. If you look at the meter on Kevin's bench over there, it's showing the same thing. So they've got a 0. Is the engine running?
No, it's not right now.
Okay. Why don't you start it and let's take a listen to it and see what so it starts, it idles. Why don't you do a light acceleration? You take it up to 3 and back. Okay, how about stabbing the gas? Can you feel any difference at all?
It's a little slower to react, almost like a feeling of a turbo lag.
Okay. We still don't have a check engine light, so let's do this. Turn the key off and start it back up again. Okay, so now the check engine light's on. Now the customer, might not have noticed, the difference in performance, but now they have a check engine light on that they can either ignore or they can take in and find out what's going on.
I don't know if
what
you
I
guys
want
can hear it, but now that it's warmed up a little bit, it's not idling very well either.
Okay. Between today and tomorrow, we're going to kind of continue this thing. I'm not trying to shut off already. I'm just letting you know that we're going to come back and maybe start looking at some things like fuel trim and stuff too when I grab the live data. But so let me just for fun go back to the live data. Oops. You can see the pressure steady. Go ahead and whoops. So when he's messing with the throttle, we're seeing a flat line on the scan tool. We're not seeing really any big pressure difference in the map sensor. So we know we basically know something's dead sensor or wiring or whatever, correct? But that illustrates what I like is that the mass airflow seems to have taken over and remedied somewhat of the performance problem, even though like I said, it still starts and runs. So is there a code stored? Why don't you turn the key off, engine off and key back on again.
We're good.
Okay, now what the problem, the thing I've kind of run into that I don't like about the Autel so far is if I get out of here to go back and check a code, when I come back, I have to repopulate this list again. But I'll do it just right now. We're getting close. We've got 5 minutes. I'm going to go ahead and read the code. So we're expecting a P107, correct? Because that's what that's what we told you in our information. That's what Hyundai says, and that's what's truly happened here. So, and the explanation is barometric pressure circuit input low. So, your discussion from here with your students is, where do you go? What would you do next? And that's where I think the comprehension, where you can base test their competency, is going to really come out. It's going to be in a verbal discussion about, how do you fix this car? No offense, but I could go to a parts store and have that code pulled up and go to Google, but where do you go from there? You start throwing parts on it, or is it truly a part? So, find that interesting. So, I'm kind of referring back here that we even tell you it's going to be a P107. So, what's the enabling criteria? You would want to look that up, have that discussion with your students, and then, the same thing. The question would be, what's next? Where would you go next? You're going to shoot the parts cannon at it, or are you going to actually, take your diagnostics to the next level? Got to find it to fix it. And then, you spend a lot of time on finding the system wiring diagram. Right now, if I pull up and I can go back to Visor, I can go, up to my the HMI and go back to the home. I can pull up wiring diagrams. I know that actually I had him, I guess I didn't tell you guys, I had him get onto the KG80 pin, which is the map sensor. So I'm going to go down to where I know that it's at. KG being this EGGM, KG is basically the designation Hyundai uses for their ECU, and 80 is the pink wire for the sensor signal. And I can go across here. Use it better without my cursor. And go down to the map sensor itself. Whoops. And so right there I have in my hands all the information I need to kind of at least know how the system works. I'm going to go back here and show you this. What is that? That's the same, that's a screenshot of that wiring diagram, and what is that? And so for the most part, I'm not watching the chat, so I don't really expect you guys to answer, but I'll take you back to this and say, if we come up and follow that same wire, that yellow wire, and go back over to here, it shows to be the intake air temperature sensor. So what's the deal? Here's the intake air temperature sensors built into the map sensor. Good to know. And then this is the KG80. This is basically where Kevin has that voltmeter plugged into right there. So that's equivalent right there. What he's doing on that breakout box is the equivalent of back probing at the computer right there without bending any wires. So questions? If you're able to and want to demonstrate, now's the time to pull out a scope too. Just have fun.
So I don't see
Okay,
coming in, Tim, but
okay.
Dan Beeson did comment that was a temp sensor. So
Okay, cool. Then having said that, when I was setting this up, we've got four actual map sensor case studies, and we've gone through one here. What I want to do tomorrow is we can kind of cut some of the preliminary stuff and maybe get to the second and third and fourth and watch what the reaction is. I'll give you a teaser, a spoiler alert. We've taken, the factory 5-volt reference and then the signal back to the computer and mess with it. In this particular study, we sent a 0 back to the computer. The next study, we're going to send a 0.8 volt. The next study, we're going to do a 1.5 volt. And then the last study, we're going to put full 5 volts back to it. So we're going to kind of come from 0 all the way up to 5 volts and see what it does to the way the engine operates and what kind of codes show up and what kind of performance issues happen. And I don't know of any other way of doing that. This is kind of cool, I think. You couldn't do it on a car. And you could wait until a customer comes in with a problem, but there you are waiting. So having said that, I want to show you one other thing. I prepared, this is kind of a cheat sheet that I would have had as a teacher. And it's almost going through just what we're doing right now. I'd clear codes. There'd be no fault. I would illustrate a known good one. I'd put this fault in, 3 and 4. And then I'd have some references down there just for me, like a cheat sheet.
So this is a storyboard.
So, yeah, yes. I think I've pushed a half an hour. Oh
Yeah,
my
you know,
gosh, how did I get a
you're right there at 2:30. So
How did I get a gratuitous shot of my grandchildren in there? Shame on me. Hopefully you guys got something out of this today. My hope is that you'll come back tomorrow and we'll proceed on to a couple other case studies and maybe get a little bit more interaction and maybe ask for maybe see what kind of live data you want to look at in relation to the scenario. So now that you know what we're going to do tomorrow, you might think about what you want to see if we can make the engine bench do, and we'll maybe make it a little bit more open-ended. So thanks for joining, and we'll see you guys tomorrow.